Welcome to the Simple M1 Application User Guide. The application consists of two major parts, a guided mental imagery portion and a saccadic task to remembered targets. The theory of application is described in this video. The M1 app incorporates motor imagery, binaural beats, vestibular stimulation and also response inhibition, all of which have been shown to reduce chronic pain symptoms. Let's take a look at some of the research which suggests that activation of the motor cortex, with techniques such as motor imagery, may be beneficial in suppressing chronic pain. From the European Journal of Physical Rehabilitation Medicine, published in 2022, the authors discuss how motor cortex stimulation has emerged as the treatment of choice for the treatment of neuropathic pain syndromes. The mechanism of action is believed to be related to the stimulation of descending pain inhibitory circuits as a result of activation of the motor cortex. This article discusses various methods, both invasive and non-invasive, by which motor cortex activation suppresses chronic, intractable pain. From that same article, the authors discuss how non-invasive activation of the motor cortex influences distributed brain networks, including the sensory, affective, and cognitive aspects of chronic pain. Interestingly, stimulation of the motor cortex mainly inhibits pain associated with hypersensitivity of the sensory pathways, and has little effect on non-pathological pain syndromes. Research published in the Cerebral Cortex Journal, June 2015, documents that merely reading action verbs from a list of words may activate the motor cortex. By having a patient choose verbs that depict motion from a list of words, activation of the cortex has been documented. The M1 app takes advantage of this phenomenon by presenting the patient with 4 images. 3 of the images are of an inanimate object, the 4th image depicts action and motor activity. The patient is instructed to tap on the image that represents an activity. Once the patient has selected the appropriate image, the action image is presented on the screen by itself. The patient is instructed to close his or her eyes and imagine performing the activity seen in the image. In this example, ice skating. By incorporating the use of bone conduction headphones, the M1 app creates a binaural beat. The app plays a 100 Hz tone in one ear and a 110 Hz tone in the opposite ear. The brain creates a third tone, known as a binaural beat. Binaural beats, produced in this way, have been shown to entrain brain oscillations. In this example, an alpha band brain oscillation entrainment will occur. Research suggests that brain oscillations in the 10 Hz alpha band may suppress chronic pain symptomatology. This study, published in Frontiers of Neuroscience, 2019, showed a correlation between 10 Hz alpha band brain oscillations and pain intensity. From the journal Neuroplasticity, published in 2021, the researchers demonstrated the relationship between alpha band oscillation and chronic pain perception. This article, published in the journal European Journal of Pain 2018, demonstrated externally driven brain entrainment in the 10 Hz alpha oscillation band, and that this brain entrainment was associated with pain suppression. So the M1 app incorporates brain entrainment via binaural beats in the 10 Hz alpha frequency band and applies this stimulus while the patient is engaging in mental imagery of physical activity. The M1 app creates a binaural beat by including a 100 Hz tone. This adds another layer of pain suppression. The vestibular system has been shown to suppress centrally generated pain. It can be activated through bone vibration of the skull at 100 Hz frequency. Bone vibration is achieved by the use of bone-conducting headphones that are widely available on the internet. This study, published in the Journal of Medicine October 2020, reviewed the literature concerning the treatment of centrally generated pain syndrome. The literature revealed that stimulation of the motor cortex, as well as stimulation of the vestibular cortex, were both effective measures for treating chronic intractable, centrally generated pain syndromes. The M1 app incorporates motor cortex stimulation to visualization, brain entrainment in alpha frequency bands, and with the use of bone conduction headphones, vestibular stimulation through skull vibration. From the journal Frontiers of Neurology 2017, this study reports that skull vibration of 100 Hz frequency produces robust vestibular activation. Some research suggests that patients suffering from chronic pain syndromes have impaired ability to inhibit their attention to the painful stimuli. This cognitive function, known as response inhibition, is believed to be localized predominantly within the right frontal lobe. The M1 app includes a task designed to enhance function of the right frontal lobe for the purposes of enhancing response inhibition and increasing the patient's ability to direct focus away from their painful symptoms. Published in the Journal of Pain Research 2020, these researchers describe a relationship between increased cognitive inhibition and pain suppression. Other researchers, publishing in the Journal of Headache and Pain 2020, reported a relationship between response inhibition and migraine pain. From that same journal article, the authors conclude that patients suffering from migraine demonstrate dysfunctional inhibitory control. The M1 app incorporates a specific eye movement, which appears to enhance activity in the right frontal lobe. From the journal Neurophysiology 2004, researchers report that saccadic eye movements to remembered targets enhance activity in the right frontal lobe. Theoretically, saccadic eye movements to the left visual field and targeted to remembered targets enhance activity in that part of the brain associated with response inhibition. This is a screenshot illustrating the M1 app's saccade to remembered target task, which is designed to enhance activity in that part of the brain that is related to response inhibition. Use of the M1 app combines 4 unique methods, which research suggests may create plasticity in the brain and provide pain relief to chronic pain sufferers.